In section 1 of chapter 14, we have the introduction of multiple regression analysis. The general multiple regression equation has k independent variables. In chapter 13, we looked at the model with one independent variable. Now, the general multiple regression equation can have many independent variables. This is an example to illustrate this concept. Salisbury Realty sells homes along the East Coast of the United States. One of the questions most frequently asked by prospective buyers is, if we purchase this home, how much can we expect to pay to heat it during the winter? The research department at Salisbury has been asked to develop some guidelines regarding heat costs for single-family homes. Three variables are thought to relate to the heating costs: the mean daily outside temperature, 2, the number of inches of insulation in the attic, and 3, the age in years of the furnace. Then the multiple linear regression is the heating cost estimated is equal to A plus B1 times the mean outside temperature plus B2 times the inches of attic insulation plus B3 age of the furnace. To investigate, Salisbury's research department selected a random sample of 20 recently sold homes and measured all four variables. And this is a table with the four variables. We have 20 homes, heating costs for each home, the outside temperature that corresponds to each case, the attic insulation in inches, and the age of furnace in years. After we run regression command in Excel, we obtain the regression equation as we did in chapter 13, and I will find this in a moment. The regression equation, that is. Well, if you look at the yellow, the highlighted part here, where on the coefficients we get the equation. The intercept is 427, and then the temperature coefficient is 4.583 negative. The insulation coefficient is minus 14.831, and the age is 6.101. Using the regression coefficients, the multiple regression equation to estimate heating costs is 427.194 minus 4.583 times x1 minus 14.831 times x2 plus 6.101 times x3. The regression coefficient for the mean outside temperature, x1, is 4.583. The coefficient is negative, which means the following: as the outside temperature increases, the cost to heat the home decreases. For every unit increase in temperature, holding the other two independent variable constant, monthly heating cost is expected to decrease by $4.583. The attic insulation variable x2 also shows an inverse relationship, or negative coefficient. The more insulation in the attic, the less the cost to heat the home. For each additional inch of insulation, the cost to heat the home is expected to decline by 14.83 months per month. The age of the furnace variable shows a direct relationship. With an older furnace, the cost to heat the home increases. For each additional year older the furnace is, the cost is expected to increase by $6.10 per month. We can apply the model for estimation. What is the estimated heating cost for a home if the mean outside temperature is, let's say, 30 degrees, there are 5 inches of insulation in the attic, and the furnace is 10 years old? Substituting the values for each of the independent variable, we can calculate the estimated cost to heat the home. In this case, the predicted cost is $276.56 per month. We just have to add 427 plus, or the negative 4.583 times 30 minus 14.831 times 5 plus 6.101 times 10. In parentheses, we just substitute each one of the x1, x2, and x3 for their corresponding values, respectively. Now we can do this for any combination of values that we can select. And that is the end of section 1 that I wanted to show you. Now in Excel, I have the same information here. How we find the regression equation. How do we find it? In data, select first, then data analysis, and then select regression. I did it before, so I'm going to repeat it. In the Y, you select the cost, and then for the X range, select the 3 independent variables. Notice that they are together. You need to do that in Excel. You first have, in your first column, you need to have the dependent variable, in this case, cost. And then all the following columns are your independent variables. In this case, there's 3 independent variables. Labels are checked because I put them in the first row. And the output range, I have it here at F4. Let me just click OK. And I get my results. And same way as the slides, my equation is 427 minus 4.58 times temperature minus 14.83 times insulation plus 6.1 times the age of the furnace.